When we think about the search for intelligent life in the universe, we are not simply referring to intelligence in a broad sense, but to a particular type of intelligence, one capable of using technology, and especially technology that can leave visible traces even over great distances, such as tens or hundreds of light years away. In this video, we want to focus on a specific aspect. What kind of civilization should be capable of leaving a technosignature? In other words, what do we really mean when we talk about technologically advanced civilizations? What might these civilizations be like, and how could we classify them? Let's try to understand it. One of the biggest challenges in the search for intelligent life in the universe is understanding exactly what we are looking for. For example, if there were intelligent life on another planet at a technological stage similar to that of our species thousands of years ago, it would be extremely difficult to notice. In fact, we might never realize its presence. The same goes for more fanciful hypotheses. If there were a technologically advanced underwater civilization that didn't use radio waves to communicate, it could be very sophisticated, but the evidence of its existence would be difficult to detect from Earth. These kinds of problems were well understood by the early scientists who, in the 1960s, began to consider the possibility of finding traces of intelligent life in the universe, such as Frank Drake. Initially, the research focused on hunting for radio signals, but there could be many other possibilities. Even in the case of radio signals, one might ask, what kind of signals should we expect? At what frequency should we search for them? In short, it's a complex problem with no easy solution. In 1964, the scientist Nikolai Kardashev proposed a classification scheme for intelligent civilizations based on a simple and fundamental parameter: the use of energy. This idea has its logic because if we look at the development of our civilization over millennia, we see a close correlation between what we call progress and the use of increasing amounts of energy. Many books have been written about the link between energy and civilization. One of the best is Energy and Civilization, by Václav Smil, a comprehensive and complete text. Returning to Kardashev's classification, he proposed that technological progress goes hand in hand with energy consumption. According to this theory, even hypothetical extraterrestrial civilizations should follow this law. Kardashev defined 3 levels in his scale. Type 1, a civilization capable of using all the available energy on its planet. For Earth, this corresponds to a power of 2 × 10⁻17 watts. Type 2, a civilization capable of using all the energy emitted by its star. In the case of the Sun, we're talking about approximately 4 × 10⁻26 watts. Type 3, a civilization capable of harnessing the energy of its entire galaxy, an enormous power of the order of 4 × 10⁻37 watts. Of course, intermediate levels can be imagined using decimal figures, such as a Type 1.3 or 2.7 civilization. This scale has generated much discussion and criticism over the years, but today we will limit ourselves to considering the original idea and asking some fundamental questions. The first question is, how does an intelligent civilization climb these 3 steps? To reach Type 1, for example, it might be necessary to harness all the energy that arrives on the planet from the star, perhaps using enormous solar panels or other advanced energy sources such as nuclear fusion or, more speculatively, matter-antimatter reactions. Becoming a Type 1 civilization is already very complicated. Currently, we are at stage 0.7 on the Kardashev scale, and it is estimated that we could reach Type 1 within 1 or 2 centuries, continuing at the current pace of development. For a Type 2 civilization, we already enter the realm of science fiction. Harnessing the energy of a star would require structures like the Dyson sphere, theorized by physicist Freeman Dyson, which would completely surround a star to capture all its energy. In reality, an undertaking of such magnitude is beyond the capabilities of a civilization like ours. As for Type 3 civilizations, we cannot even imagine how it would be possible to use the energy of an entire galaxy. Speculative ideas include using the energy stored in supermassive black holes at the center of galaxies, but these scenarios go beyond our current understanding. If we accept this scale, it is clear that Type 2 and 3 civilizations should leave evident traces in the galaxy. Kardashev calculated that these civilizations could transmit information with such power that it would cover enormous distances, making them very visible. However, so far, we have found nothing. This is a significant result, especially for Type 3 civilizations, which should be so evident that they could not escape our observation. The discussion remains open for Type 2 and 1 civilizations, more similar to ours. But there is another aspect to consider. In the years since Kardashev's proposal, we have become more aware of the limits of technological development and the difficulties associated with using increasing amounts of energy. It is by no means certain that technological progress based on the increasing use of energy can continue indefinitely. For example, as early as 1972, the Club of Rome published a study, The Limits to Growth, which demonstrated that the increasing use of resources and energy, combined with population growth, would not be sustainable in the long term. Many subsequent studies have confirmed these conclusions. A planet is a closed system with limited resources, and it may not be possible to move from Type 1 to Type 2 without compromising the planetary environment. In summary, to become a Type 2 civilization capable of colonizing other planets, one must first find a way to progress without destroying one's own planet. But it is by no means obvious that this is possible. Perhaps all intelligent civilizations in the universe face this problem. The solution might be to find a sustainable balance, or technological progress itself might provide the answers. We do not know the definitive answer, but it is clear that the Kardashev scale, while speculative, also offers us a reflection on our own civilization. Thank you for watching. Please like the video to support us and subscribe to the channel.